Mathematics and Physics Part 2. Today our topic is binomial theorem. If n is any number, it may be a positive value, negative value or even a fraction value, and x is any real number such that it lies between x1 and -1, x lies between -1 and +1. Then according to binomial theorem, 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial and x square, n into n minus 1 n minus 2 3 factorial x cube, then n into n minus 1 n minus 2 n minus 3 by 4 factorial x power 4 and so on. What is this 2 factorial? Factorial 2. Nothing but this, we are writing this as 2 factorial, which is given by 2 into 1. That is nothing but the value of magnitude of this one is 2. Similarly, factorial 3, meaning of this one is 3 factorial. This is 3 into 2 into 1, which is equal to 6. Similarly, factorial 4, which is given by 4 factorial, 4 into 3 into 2 into 1. This is 24. 4 3s are 12, 2 is 24. 4 and so on. And this is according to binomial theorem. Now, if you take this equation, 1 plus x whole power n can be written as 1 plus nx plus, this is n into n minus 1 by 2 factorial is 2 here into x square, and next one this value we know 6 into x cube, sorry, here n into n minus 1 into n minus 2 by 3 factorial is 6 x cube and so on. But students, in this expression, if x is very small, this is most important. If x is very small, x is much smaller than 1. So x value is very small. Then if you take this binomial expansion according to binomial theorem, this will become 1 plus nx plus the remaining term. Here x is very small, x square will be very small. Suppose x is equal to 0.001. When compared to 1, this value is very small. Then what is x square? This is 0.001 into 0.001. This is nothing but 10 power minus 3, 10 power minus 3, 10 power minus 6. 0.00001. This is x square. So if x is very small, x itself is very small, x itself is very small, then x square will be very small. So we can consider this x square nearly equal to 0 because this value is very small. That's why in this expansion, this x cube will be very small, x square will be very small. That's why whenever x is very small, this is most important, and we are going to use this concept so many times in physics. If x is very smaller than 1 plus x whole power n will become 1 plus nx. The other term will nearly equal to 0. The third term will become 0. The fourth term, x cube, will be very small, 0, and remaining terms will become 0. That's why finally what we can write in the binomial expansion, 1 plus x whole power 1 plus x whole power n will become just 1 plus nx, just 1 plus nx. When we can use this one, if the x value is very small, x value is very small. So this is true only if x is very small. If x value is much smaller than 1, then only this given statement is correct. For all other values of x, we have to use this binomial theorem. Now, suppose if you take 1 plus x whole power n and condition is First condition is if x is much smaller than 1, then this will become 1 plus nx will be 1 plus x whole power and become 1 plus nx. This is equation 1. Equation 2, 1 minus x whole power n is equal to 1 minus nx. Directly you can use this only if x is much smaller than 1. Similarly, 1 plus x whole power minus n is equal to 1 minus nx, because this power will just come here. And the fourth one, 1 minus x whole power minus n is equal 1 minus n into x, which is equal to 1 plus nx. These are the four formulas that you have to remember, and all these formulas are valid or correct if x is much smaller than 1. For example, if you want to find out 1 plus 0.0003 whole square, this is one of the example. Now first we have to check whether it is in the form of 1 plus x whole power n. Yes, this is in the form of 1 plus x whole power n, this is 1, and this value is x whole power n. Then whether we can apply this formula or not, for checking that one we have to check whether x is much smaller than 1 or not. If you observe this one, this value 0.0003 smaller than 1. So from this, students, directly we can write this value as 1 plus 2 into, because the power will come in front of this smaller x value, because this is 1 plus nx. First 1 all I wrote, n is here 2 and x is 0.0003. From this 1 plus 0.0006. So the value of this one, without doing the multiplication, directly by using this concept, this will become 1.0006. This is the one of the model here. Now one more problem we are writing. Second problem, example 2, 1 minus 0.0007 whole power minus 3. First of all, to get the value, to find this, we need to check whether x is much smaller than 1 or not. And by observation, you can see this is much lesser than 1. 0.0007 much smaller than 1. So directly we can apply 1 minus 3 into 0.0007. This is the value. From this, minus of minus plus 3 into 0.0007. From this we can write 1 plus, this is 0.0021. The answer is 1.0021. So this is example 2. Similarly, if you take one more example here, example 3, please remember I am repeating, 1 plus x whole power n is 1 plus x whole power n is 1 plus nx if and only if x is much smaller than 1, then only use this formula. Otherwise, we have to use 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1, n minus 2 by 3 factorial x cube, and so on. But here for small values. Now here also one more example. 1 plus 0.000003 whole power 9. Directly you can do it. Here this value we know this is very small, much smaller than 1. So directly we can write the answer 1 plus, you just multiply 9 with 3. So when we are multiplying these, students, be careful. When we are multiplying this 9 with 3, this 9 3s are 27. So you have to write in place of last 2 digits you write 27. So these 2 digits are over. The remaining terms are 0, 0, 0, 0, 0. So the answer for this one will become 1.00000027. Fourth problem, evaluate 1001 whole power 1 by 3 up to 3 decimal places. You see this question, if you observe the question clearly, the given value 1001 whole power 1 by 3 can be written as 1000 plus 1 whole power 1 by 3. This 1000 can also be written as 10 cube plus 1 whole power 1 by 3. Now if you take 10 cube common, you will get 1 plus 1 by 10 power 3 whole power 1 by 3, because 10 power 1 into 1 is 10 power 3. 10 power 3 into 10 power 3 into 1 by 10 power 3 will become 1 whole power 3. So now this can be written as 10 power 3 whole power 1 by 3, 1 plus 1 by 10 power 3 whole power 1 by 3. This 3 get cancelled, this will become 10. This is 1 plus 1 by 1000. This is 1 by 1000 whole power 1 by 3. Now, here we can write 1001 whole power 1 by 3 can be written as the now 10 into 1 plus 1 by 1000 is 0.001 whole power 1 by 3. Now, we know that whenever if the equation is in the form of 1 plus x whole power n, where x is much smaller than 1, this can be written as 1 plus nx. The given number is not in this form, but we converted this into the required form, that is 1 plus x whole power n. So this 10 won't change. This is in the form of, because 0.001 much smaller than 1. So now we can apply this 1 plus x whole power n is equal to 1 plus nx. Substitute this one, 1 plus, this power will come in front of this small number, 1 by 3, 0.001. So this will become 10, 1 plus 0.001 by 3. This will become 10 into, now you can write this as 1 plus 0.001 by 3 is 033. So this will become 10 into 1.00033, which can be written as 10 into 1. If you multiply this one, this point will come this side, 10.0033. So minimum they need up to 3 decimals or 4 decimals. Up to 3 decimals means so you can stop here. So this will be the answer for this question. Similarly, in physics, where we can use this type of binomial approximation. This is called binomial approximation. Binomial approximation. Suppose if you take a gravitational lesson, in gravitation lesson, suppose if you take earth, the small g on surface of earth, we studied this in high school standard, sir. Small g value 9.8. So in this small g, if you take our earth, this is the earth, and if you take any one point on the surface of earth, any one point, small g here on the surface of earth is 9.8 meter per second square. But if you go away from the earth, above the surface of earth or deep into the earth, small g always decreases. Either you go up, small g will become 9.6, 9.3, 9.1 or 8.7, like that. At greater height, small g decreases. Similarly, if you go deep into the earth, also small g decreases. Now, above the surface of earth, at a height h, above the surface of earth. So here, we will learn this in PUC, but I am just giving that expression today itself so that you will get an idea where we are using this binomial approximation in physics. So small g at a height above the surface of earth is given by gr square by r plus h whole square. You will learn this in first PUC physics, in first PUC 8th lesson. First PUC 8th lesson. Now, in this case, if the height is very small, if height is 1000 kilometers, 2000 kilometers, then you can use this formula. But if the height is very small, this is for greater heights. This is the formula where you can use greater height above the surface of earth. But if this height is very small, general students, please remember this concept. The radius of earth is 6400 kilometers. This radius is equal to 6400 kilometers, or you can write 6.4 into 10 power 6 meters. This is the radius of earth. But if the height is also in kilometers, then you have to use this formula. But if height is only 40 meters, this is very small, then we have to use this formula in another way, that is g at a small height is given by gr square by r plus h whole square. You just divide this with r square and divide this with r square. Both numerator and denominator divide with r square. So this r square also will cancel, and we have g in the numerator, and denominator we have r plus h by r whole square. Because this is r plus h whole square, this is r square. So both are having square. So you can write small g by, what is r by r? 1. H by r whole square. And now we can see the formula that we learnt in binomial theorem. 1 plus x whole power n is equal to 1 plus nx if x much smaller than 1. Now you see this formula, the same formula I am writing here, 1 plus h by r whole square. This can be written as 1 plus, this 2 will come here, 2 into h by r, if the condition is the second term, this one should be very, very small. So here h by r should be very, very small, should be much smaller than 1. Yes, as height is very small, 40 meters, and radius is 6400 kilometers. So let us say h is given as 40 meters, radius is a constant 6400 kilo, means another 3 zeros meters. Then what is h by r? This is 40 meters, this is 6400 kilometers. Then this value will be much smaller than 1. Then we have to write here g at a height is given by g by, this 2 will come here, this will become 1 plus 2h by r whole power 1. And once again, if you take this up, you can write this as 1 plus, if you take this denominator into numerator, you can write 1 plus h by r whole power minus 2. This is g into, this minus 2 will come here, 1 minus 2h by r. So this is gh, g value at a height, h. Similarly, if you take this one, this whole power 1 is there. If you take this denominator into numerator, once again you can write g into, this is plus 1, when it goes up this will become minus 1. 1 plus 2h by r whole power minus 1. This will become g into 1 minus 2h by r. The same form that we obtained previously. So here, in this gravitational lesson, we are using this binomial approximation. Binomial theorem, it describes the algebraic expansion of powers of a binomial. Binomial is 2 terms, x plus y. So already we studied this in high school standard. x plus y whole power 1 is given by, this is x power 1 plus y power 1, just power is 1 is, then x plus y is x plus y only. But if you take x plus y whole square, this is x square plus 2xy plus y square. This is a plus b whole square is equal to a square plus 2ab plus b square. We studied this so many times, used this formula so many times in a school standard. Now, x plus y whole cube. This can also be written directly because we can remember this formula easily. This is x cube plus 3x square y plus 3xy square plus y cube. So till then there is no problem. But once if you ask you to write this x plus y whole power 4, then most of the students will fail to write this one. The actual expression for this one is x power 4 plus 4x cube y plus 6x square y square plus 4xy cube plus y power 4. So this is x plus y whole power 4. Then x plus y whole power 5 can also be written easily. But to find this one, students, if you observe this expansion, so first I will take the second order equation. In the second order equation, x plus y whole square can be written as x plus y whole square can be written as, if you observe this one, because we are familiar with this one, we use this one so many times. And if you observe this one, here the coefficient of x square is 1, the second coefficient is 2, and then this is 1. So these coefficients are very, very important. 1, this is 2, and then 1. And next one, if you observe this one, for this 1, 3, 3, 1. And for next one, 1, 4, 6, 4, 1. Next one, 1, 5, 10, 10, 5, and 1. For this, students, we have a triangle known as Pascal's triangle. So I am drawing this triangle here, the Pascal's triangle. So in this Pascal's triangle, so this is called Pascal's triangle, very simple. There is no much confusion here. If you observe the first one, x plus y whole power 1, x plus y whole power 1. In this 1, power for this one is 1, power for this one is 1, and the coefficient for x and y, for both x and y powers, the powers are equal to 1 and coefficients are 1. In the second one, if you observe this one, this is power x square, then x power 1, then x power 0. Here x term is not there, because actually x power 0 is present here. This is x power 0. But what is x power 0? The x power 0 is exactly equal to 1. And if you observe the next one, students, clearly if you observe it, this x power 3 and x power 2, this is x power 1. And here, even though it is not there, we can write this as x power 0. Similarly, if you take, here we have y power 0. Y power 0 is 1 only. This is y power 1, y power 2, y power 3. Now, if you take the next one, in the next one, we have power 4, x power 4, then x power 3, then x power 2, then x power 1, then x power 0. So x power is decreasing gradually. At the same time, what happens to the y power? So here we have y power 0, y power 1, y power 2, y power 3, the fourth one is y power 4. So while expansion of this binomials, in this expansion, please remember x power of x decreases by 1 from each term to next term. Power of x decreases by 1. At the same time, the power of y increases by same 1 for each term, for each successive term, here also for each term. Now we will see this Pascal's triangle. This triangle is called Pascal's triangle. By using this triangle, we can give the coefficients easily, because already just now we found the relation between x power and y power. So how to write this coefficients? We will see. First coefficient 1 and 1. This is 1, this is 1. The next coefficient, I am talking only about the coefficients, the number just before those variables. This will be 1, this will be 1, because here this is 1, this is also 1, but the middle term is 2. But how to get this 2? If you observe the students, if you add this one, if you add these two, you will get 2 here. So this is a middle term 2. And then the next coefficients 1, 3, 3, 1. So I am writing first this term 1, this term 1, 2 plus 1 together they will get 3 here. Similarly 1 plus 2 together we will get 3 here. So these are the coefficients in the x plus y whole cube expansion. Next one, the coefficients for the last 2 terms, that is x power n and y power n, must be 1 and 1 only. So I am writing 1 and 1. So this term will come 1 plus 3, 4, 3 plus 3. If you add these 3, you will get 6 here. This is 6. And 3 plus 1, if you add these 2, 4. And then the last term is 1. Next, I am going to write the next one. For x plus y whole power 5, this will be 1, this will be 1. And if you add this 1 and 4, you will get 5. 4 and 6, you will get 10. 6 and 4, you will get 10. 4 and 1, you will get 5. So these are the values that I am going to get for the last expansion, that is x plus y whole power 5 here. These are the values. So you can extend up to 10 power x plus y whole power 10 also. But if it is x plus y whole power 25, x plus y whole power 45, then we cannot draw such a big graph or triangles, Pascal's triangles in our notes. Then we have to use 1 plus x or x plus y whole power n is equal to, we have to use the original binomial theorem. We will discuss that later. X plus y whole power 5. So this expansion, first whole power 5, this is for whole power 1, these are the coefficients for whole power 2, these are the coefficients power 3, these are the coefficients in the expansion of power 4, and these are the coefficients for power 5. So I need x plus y whole power 5. So I need these coefficients. So first coefficient is 1. And the first power for x is 5. And even though here y term is there, whose power is 0. Plus, now I need to write the second coefficient here from the Pascal's triangle. We can write this as 5. The power of x decreases by 1 for each term. So here x power 5. Next, this will become x power 4 y power 1, because x power decreases, at the same time y power increases by 1. So I am increasing y power 0, y power 1. Then the next coefficient is 10. So I am getting 10 x power 3, power decreases by 1, y power increases by 1. Then after this, next term is 10 x square y square. Here this is y power 2, students, because power should increase by 1. Here x cube y 3. Then the next term is 5, coefficient is 5. So this is 5 into x y power 4. The next one is 1. This is 1 into x power 0 y power 5. We know that x power 0 is equal, y power 0 is equal to 1. So now in this expansion we can write y power 0, in place of this we can write 1, x power 0 also we can write as 1. Now this x plus y whole power 5 can be written as x power 5, 5x power 4y, 10x cube y square, then 10x square y cube plus 5x y power 4 plus y power 5. The algebraic identities. So we have studied this so many times in school standard. The first one, a plus b whole square is, from the Pascal's triangle the quotient is 1, a square. Next quotient will be 2, a power 1, b power 1, and the next quotient, last quotient, because this is the last term. For first and last term the quotient is always equal to 1, and this will become b square. So we can write this as a square plus 2ab plus b square. Similarly, a minus b whole square. For the students, 1 into a square minus 2 a power 1 b power 1 plus 1 into b square. So whenever that minus is present in the expansion, minus is present in this expansion, always the first term will get a positive value, second term will get negative value, and the third term will get positive value. So alternative positive negative terms should be written in this a minus b whole square expansion. So in this expansion we can write this as a square minus 2ab plus b square. Once again I am telling, positive followed by negative, then followed by positive. If you follow that a square, a power 1, a power 0, b power 0, b power 1, b square. Then third one, a plus b whole square plus a minus b whole square. We know a plus b whole square, you know a minus b whole square. So a plus b whole square can be written as a square plus b square plus 2ab. For this I am adding this a minus b whole square, which can be written as a square plus b square minus 2ab. I am just changing these two terms. This plus 2ab minus 2ab cancel. This is a square plus b square plus a square plus b square. 2a square plus 2b square. This is a plus b whole square plus a minus b whole square. The next term, a plus b whole square minus b whole square. First, this is a square plus b square plus 2ab minus a square plus b square minus 2ab. Plus a square minus a square cancel, b square and b square cancel, 2ab. Minus of minus, be careful, most of the students make mistake. While multiplying these two, they are not considering this minus, they are considering only this minus. So be careful, this is 2ab. Minus of minus will become plus. So this will become 2ab plus 2ab, which is equal to 4ab. Then here also I am making a plus b whole square. Already we have a plus b whole square and we have a minus b whole square. I want a plus b whole square in terms of a minus b whole square. This can be written as a minus b whole square plus 4ab. Students, how to get this one? You just check once. This is one of the important formula while solving problems in physics. This you can write a minus b whole square written as a square plus b square minus 2ab. This is the second expression, a square plus b square minus 2ab. For that I am adding 4ab. Then I will get, first two terms will not change, they remains as a square plus b square plus 4ab minus 2ab will become plus 2ab, which is equal to a plus b whole square. So to get a plus b whole square, a minus b whole square plus 4ab. Similarly, a minus b whole square can be written as a plus b whole square minus 4ab. This can also be written, right clicks, a square plus b square plus 2ab minus 4ab. 2ab minus 4ab is minus 2ab, which is equal to a square plus b square minus 2ab, which is equal to a minus b whole square. The next one, a plus b plus c whole square can be written as a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So this is a seventh one. Eighth one, students, in the same category, eighth formula, a plus b whole cube, and ninth one a minus b whole cube, 10th one a square minus b square. So a plus b whole cube, from Pascal's triangles, if you have some knowledge on binomial theorem, expansion of binomial, we can write a cube plus 3a square b plus 3ab square plus b cube. This is one method of expansion, this by using Pascal's triangle and also binomial expansion concept. This can be written as a cube minus 3a square b plus 3ab square minus b cube. Already I told you, whenever these expansions are given, one is positive, the next one should be negative, and then positive and negative. If you are following that decrease in power, a cube, a square, a power 1, a power 0, b power 0, b power 1, b square, b power 3, then we can write this very easily. This is plus followed by minus, plus followed by minus. Then what about this a square minus b square? This is nothing but a plus b into a minus b, which can be written as a square minus b square. As in this case, this is a cube plus b cube. I am taking the first term and the last term first, plus here if you take 3ab common, so this will become 3ab into a plus b, you will get the same expansion. Similarly here, first term and the last term with the symbols a cube minus b cube plus 3ab into a minus b. So we will check it once. A cube is okay, a b cube is okay, plus 3ab into a, this will become 3a square b, but this is minus 3ab square. So that's why this symbols we have to replace this with minus here. This is minus. Then we will check it. A cube, b cube already exists in there. A cube minus b cube minus 3a square b, minus of minus will become plus. Now problem from physics where we are using these concepts. So the sum of two charges is equal to 10 coulombs and their product is 24 coulomb square. Then the two charges have magnitudes of dash coulomb and dash coulomb. This is the given question, students. We will learn this concept in second PUC. So now, as we are learning this concepts of binomial expansion before first PUC itself, we can solve this problem by taking the concept of here sum of two charges. We don't know those two charges. Let the charges be Q1 and Q2. These are the two charges. Now, the sum of these two charges is 10 coulombs. So here they have given, I am going to write this as Q1 plus Q2 is equal to 10. I am not writing that unit, just number. Then product of these two charges, Q1 into Q2 is equal to 24. I want Q1 and Q2 values. Here sum of the two charges, product of the two charges. I want Q1 and Q2. To get Q1 and Q2, I need to eliminate Q2 to get Q1, and I need to eliminate Q1 to get Q2. So what I am going to do now, we know that A plus B whole square is equal A minus B whole square plus 4AB. I am using this concept to solve this problem. And here A is Q1, B is Q2, whole square is equal Q1 minus Q2 whole square plus 4 into Q1 Q2. The same thing I am applying here, Q1 Q2, but we know Q1 plus Q2 is equal to 10. So we know this value, so I am writing this as 10 square is equal Q1 minus Q2 is not known here, not known value, unknown value. So 4 times of product of the two charges according to the problem is 24. This is 24. So now from this 10 square is 100. So we can write this as 100 is equal Q1 minus Q2 whole square plus 24 fours are 96. If you bring this 96 here, 100 minus 96 is equal Q1 minus Q2 whole square, which is equal to 4. 100 minus 96 is 4. So from this we can write Q1 minus Q2 is equal to root 4, which is equal to plus or minus 2. Now, so after getting this values, Q1 plus Q2 is 10 and Q1 minus Q2 is equal to 2. Now, you just bring this Q1 plus Q2, here Q1 plus Q2 is equal to 10. By adding these two, 2Q1 will become 12, Q1 is equal to 6 coulombs. This is the first answer. And from this, this is 6 plus Q2 is 10, 6 plus Q2 is equal to 10, Q2 is equal to 10 minus 6, which can be written as 4. So I got these two values. Now the answer for this one is 6 coulombs, for this one is 4 coulombs. And we can verify this also. 6 plus 4 is 10, 6 into 4 is equal to 24. Rules for factorization. So actually this is the continuation of yesterday's topic, that is finding roots of an equation by finding the discriminant first. So in the previous class we have used this minus b plus or minus b square minus 4ac by 2a. From this you will get two roots. We call those roots as alpha and beta. And the equation is, this will become x is equal to alpha, here x is equal to beta. So this is x minus alpha, this is x minus beta. If you multiply these two, you should get 0. This is the quadratic equation. So x minus alpha into x minus beta is equal x square minus sum of the roots into product of the roots alpha into beta. Now, if you take this a square plus b square, this is obtained by multiplying a plus b into a minus b. We have used this so many times in schools. Then if you take a cube minus b cube, This is a minus b into, some students they are writing a cube minus b cube as a minus b into a square plus b square only. That is wrong, students. And the middle term you will get one more ab here. Similarly, a cube plus b cube is same ditto a plus b, but here you will get minus, and by expansion you will find you will get the same point here. So we will see a into a square a cube, a into minus a by minus a square b, a into b square a b square, b into a b a square, b into this minus a b square, b into b, this is plus b cube. So if you observe this one, ba square minus ba square cancel, minus ab square plus ab square cancel, the remaining terms are a cube minus b cube. So be careful, a cube plus b cube is a plus b into a square minus ab plus b square. Why? Because some students they may think that here we have plus, so here plus, why we should get we should write minus here. If you write minus, then only this expression will become correct. Similarly, suppose if you take x power 4 plus x plus 1 can be written as x square plus x plus 1, x square minus x plus 1, and if you multiply these two, you will get this equation. Similarly, a plus a cube plus b cube plus c cube minus 3abc can be written as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, which can also be written as half into a plus b plus c into a minus b whole square plus b minus c whole square plus c minus a whole square. And if you expand this one and adding, you will get half of this one. Then x cube minus a plus b into x into a into b. This is nothing but x square minus a plus b into alpha plus beta into x into alpha and beta. These are the sum of the roots. This is the product of roots. So here first x will become a, x will become b. So product of these two will become x square plus a plus b into x into ab. Similarly, if it is not minus, then this term will become x plus a and x minus b. In this, students, this x will become x minus a 0. So x is equal to plus a or x is equal to plus b. For this equation solution is x is equal to plus a and x is equal to plus b. But for this equation, x plus a is 0, x is equal to minus a. So you will get x is equal to minus a, x is equal to minus b. These are the roots for this equation. The last one, x power n minus 1 can be written as x minus 1. First you bring it out. Then x power n minus 1, then x power n minus 2, x power n minus 3, so on, x square, x power 1, this will become x power 0 is 1. Just like x cube minus 1 can be written as x minus 1. Here n is equal to 3, so we will get x power 3 minus 1, that is x square. Then next term 2 minus 2, because x is n is equal to 3, 3 minus 2, which is x, plus next one 3 minus 3, x power 0 1. So already we got this one. This is the equation.